Every year, the world produces more than 50 million tons of electronic waste. Old computers, tablets, and phones are replaced by newer models and end up forgotten in drawers or stacked in warehouses. In Asia alone, the amount of tech waste is growing faster than any other type of urban trash. What most people don't realize is that inside these discarded devices lies a hidden fortune made of tiny traces of gold, silver, and copper, buried between wires and circuit boards. Picture a mountain of green circuit boards, colorful cables, and metal casings. Each one contains small fragments of precious metals that, when combined, can yield more gold than many active mines around the world. This is the reality driving a new kind of industry. Factories dedicated to recovering and transforming what once seemed lost into pure, reusable raw materials. In the heart of China, one of these massive facilities operates on a colossal scale, processing tons of electronic waste every single day. Each truck that arrives carries not just discarded technology, but an opportunity to recover valuable metals and reduce the environmental damage caused by improper disposal. Inside, the impossible becomes routine, as what was built to last only a few years is reborn in another form. China has become the global center of electronic recycling. The country receives tons of discarded equipment from companies and consumers all over the world. Entire industrial complexes have been built to handle this type of material exclusively. Here, the focus is not only on reuse but on efficiency in every stage of production, turning what would be waste into a valuable resource for the tech industry. Inside these facilities, the view is astonishing. Piles of computers and phones arrive stacked on trucks and are unloaded onto huge metal platforms. The sound of conveyor belts and the synchronized movement of workers create a precise industrial rhythm. The goal is simple: to separate, dismantle, and recover as much metal and material as possible, minimizing waste and giving value back to the economy. The impact goes far beyond profit. Every pound of gold or copper recovered prevents the need for new mines, saving energy and reducing emissions. This quiet yet powerful work represents a modern form of sustainability, where engineering and the environment share the same purpose: turning waste into value. If you enjoy learning how incredible things are made and want to see more real industrial processes, make sure to subscribe to the channel. That small action helps us keep producing new content and sharing stories from the factories that move our world. Tell us in the comments where you are watching from and what you would like to see next. The cycle begins at the factory gate, where trucks unload tons of e-waste collected from cities and technology companies. Computers, laptops, and phones are stacked and sent to the sorting area. Each piece is separated according to its material and potential for recovery. Batteries, cables, and boards are removed with precision, forming a disassembly line that works slowly but efficiently. Next comes the mechanical and manual sorting stage. Conveyor belts move components forward while high-powered magnets and sensors separate ferrous and non-ferrous metals. Trained workers inspect each batch, removing plastics and debris that could contaminate the process. It is a combination of advanced technology and human attention that ensures the purity of the final result. Then the circuit boards are shredded into tiny pieces. The resulting mix goes through machines that use air, vibration, and magnetic fields to separate metal particles from non-metal ones. Gradually, gold and copper begin to stand out from the fine dust left behind. From there, the material moves to the smelting area, where furnaces reach temperatures above 2000 degrees Fahrenheit. Inside the furnaces, the heat transforms the dust into drops of glowing liquid metal. Gold, copper, and silver are separated by their density, forming solid blocks of pure raw material. These blocks are shipped to companies that make new components, wires, cables, and even jewelry. What started as discarded technology now returns to the market as valuable material, completing the manufacturing cycle and showing how things are made inside China's most advanced factories. Extracting precious metals from electronic waste requires precision and control. 1 ton of circuit boards can contain about 10 ounces of gold, which is more than many traditional mines can produce. To achieve this purity, the factory uses a chemical separation system that dissolves the metals into liquid and then extracts them in a controlled process. The result is a bright and dense material ready to be melted again. The furnaces operate at temperatures above 2200 degrees Fahrenheit. Inside, the heat is constant and monitored by digital sensors that automatically adjust the flame's intensity. Gold and copper separate naturally by density, forming distinct layers that are later cooled, cut into blocks, and stored. Even the fine dust from earlier stages is collected and returned to the purification cycle. This efficiency has a direct effect on the economy. Recovering metals from old electronics can cost up to 10 times less than mining the same amount from the earth. It also saves energy and prevents soil contamination from toxic waste. What was once considered junk is now treated as a renewable source of raw material, a clear example of modern manufacturing built on precision engineering. As the world searches for sustainable solutions, these factories prove that innovation and responsibility can work together. Each batch processed means less pollution, less waste, and more awareness about where our electronics end up. Technological progress does not have to mean destruction. It can mean renewal. And next, we will see how this entire movement began and how it grew into one of the most impressive industries on the planet. Electronic recycling is a relatively new industry, born out of necessity. In the 1980s, as the use of computers expanded rapidly, the improper disposal of equipment became a global problem. Industrialized nations were accumulating tons of unused technology with nowhere to send it. China was one of the first countries to see opportunity in this challenge. Small workshops began to appear, dedicated to dismantling and reusing components from discarded devices. Over the years, the process evolved from manual and rudimentary to fully automated and highly efficient. Factories began adopting advanced mechanical systems and controlled chemical methods capable of separating precious metals much more effectively. What used to be done by a handful of workers in local shops turned into a complex industrial chain, supported by research centers and environmental regulations. The goal was clear: recover hidden value from waste and build a sustainable new market. Today, China leads the world in recycled metals recovered from electronics. The technology used in these factories is the result of decades of refinement. Engineers have developed safer machines that can operate at high temperatures with precision and without contamination. Each technical improvement increased production capacity and reduced environmental impact, positioning the country as a global reference in industrial recycling. This progress is not only economic but also symbolic. It shows how engineering can correct the excesses of modern life. What began as an environmental challenge has become a model of smart, efficient, and sustainable manufacturing. The story of this industry is still being written, and the next decades promise even more impressive advances. Now that you've seen how this process works, it's impossible not to rethink the fate of our own electronic devices. Every old phone forgotten in a drawer holds inside it gold, copper, and other materials that could be reused. When these items are properly recycled, they re-enter the production cycle, reducing environmental impact and strengthening an industry that combines technology with sustainability. These factories prove that innovation and responsibility can go hand in hand. Modern engineering shows that we don't need to open new mines to supply the world with valuable metals. We just need to make better use of what we already have. It's a powerful lesson about how things are made and how hidden potential can be found within what we once considered waste. And now I want to hear from you. Have you ever thought about recycling your old computer or cell phone? Did you know it could be full of precious metals waiting to be recovered? Tell us in the comments what you thought of this manufacturing process and what kind of factory you'd like to see next. Don't forget to subscribe to the channel and leave a like. That small gesture helps us keep creating and brings more real stories from the factories and processes that shape our modern world. Inside these factories, the cycle of technology takes on a new meaning. Computers and phones that once connected people and stored memories are transformed again into raw materials, ready to give life to new products. Nothing is lost. Every dismantled piece, every separated wire, and every purified gram of metal represents one more step toward a more sustainable and conscious future. The process is a true lesson in engineering applied to environmental preservation. Instead of extracting from nature what has already been taken, these industries show that recovery, refinement, and reuse are possible. The result is a balance between progress and responsibility, a model that inspires other areas of modern manufacturing and proves that technology and sustainability are not opposites but allies. Watching liquid gold flow from the furnaces or solid copper emerging from the presses is nothing short of fascinating. Each metallic glow represents effort, research, and innovation. That is the essence of factory videos and production processes that reveal how things are made inside places most people will never see in person. And so the cycle closes only to begin again. Today's electronic waste can become tomorrow's valuable material. While these factories continue to transform the disposable into the essential, we'll keep uncovering the stories behind the world's most powerful industries.